Hello, good afternoon, all of you. This is Dr. U. Raghavendra, Assistant Professor of Chemistry, MVS Government Degree and Physics College, Mahabub Nagar, Telangana. In this video, today I want to explain about hydroxy compounds. This is my introduction. Okay, next. This topic, that is hydroxy compound, divided into many parts. It is the first part. Today I want to discuss about the part 1 of the hydroxy compound. In part 1, what are the list of the contents? Now I want to go discuss. The first one is introduction. Introduction, classification, nomenclature. Okay, next. First one, introduction. Here the hydroxy compounds are one type of organic compounds where the compounds have hydroxy group, that is OH group, as a main functional group. Here one thing we want to know about the functional group. This is functional group. What is functional group? Functional group is nothing but it is a group of atom, or simply sometimes it may be single atom. Majority cases functional group is group of atoms. By using this functional group, we can explain all the properties of the compound. That is all the properties, that is physical as well as chemical properties of the compound generally depends on the functional group of the compound. So in hydroxy compounds, the functional group is OH. That is the compounds which have all the compounds which have hydroxy group don't falls into the category of hydroxy compounds. Even some compounds contains OH group. They may also contain some other functional groups which are uh, which have higher priority than that of the hydroxy group, such as carboxylic acid, aldehydes, ketones, as well as carboxylic acid derivatives. So the compounds which have OH group as a main functional group generally considered as hydroxy compounds. The general formula of hydroxy compounds is it is ROH. ROH. Here R is hydrocarbon part of the hydroxy compound, hydrocarbon radical. R may be aliphatic nature, may contains aromatic nature also. It may be aliphatic or it may be aromatic in nature, whatever it may be. Generally the hydroxy compounds or the majority of the functional group containing compounds are generally derivatives of the hydrocarbons. Hydrocarbons are nothing but the compounds which have carbon and hydrogen, generally known as hydrocarbons. Here also hydroxy compounds are the one of the derivatives of the hydrocarbons. That is mainly the hydroxy compound derived from alkanes. By replacing one of the hydrogens of the alkanes with hydroxy group, then we get corresponding hydroxy compound as shown here. It is RH, that is hydrocarbon. Here we eliminate or we remove H from the RH and adding OH, then we get corresponding hydroxy compound, that is ROH. So simply hydroxy compounds are derivatives of hydrocarbons. Next, okay, fine. Next, classification of the hydroxy compounds. Mainly there are two types of classification per hydroxy compounds. The first one is based on the nature of the R group present in ROH, that is hydroxy compound. In hydroxy compound, that is based on the nature of the R in hydroxy compound, we can classify the hydroxy compounds. If R group in hydroxy compound is aliphatic, then those hydroxy compounds considered as alcohols. If R is aliphatic in nature, those hydroxy compounds generally considered as alcohols. If R group is aromatic in a, sorry, if R group is aromatic, if R group is aromatic in a given hydroxy compound, then the hydroxy compounds generally considered as phenols. In the case of phenols, that is aromatic hydroxy compounds, the OH group is directly attached to rin ring. Okay, it is the classification of hydroxy compounds based on nature of, or that is nature of the hydrocarbon radical part. Okay, next examples for phenols and alcohols. There are some examples. I want to give some examples for alcohols and phenols. Here, first of all, alcohols. The first one is CH3OH, methyl alcohol. CH3OH, methyl alcohol. CH3CH2OH, ethyl alcohol. Next, CH3CH2CH2OH, in profile alcohol. These are aliphatic hydroxy compounds, so they falls into the category of alcohols. Here, if you observe the fourth one, it contains aromatic ring, that is benzene ring, but it don't falls into the category of phenols, because here the hydroxy group is attached to aliphatic side chain, that is attached to CH2, but it didn't attach it to aromatic ring, so it is the aliphatic hydroxy compound, that is it belongs to alcohols. Next, examples for phenols. The first one, here the first one is phenol. Generally the compound, that is the compound in where the hydroxy group is directly attached to benzene ring is considered as phenol. So all other aromatic hydroxy compounds also named as phenols, but the main phenol is, that is benzenol, where the hydroxy group is directly attached to benzene ring, it is phenol. The second one is, it is orthonitrophenol, because here the nitro group is and hydroxy group are situated at ortho position each other, so it is nitrophenol. Here the hydroxy group is main functional group, here nitro group is substituent, so it is orthonitrophenol. Next, the third one, here it is alpha naphthol or 1-naphthol, that is the ring is naphthalene ring. Here it is first position, second, third, fourth, just like we have to count in clockwise direction. So here the watch is attached to one position or alpha position, so it is 1-naphthol or alpha naphthol. The fourth one is, it is example for cresol. If the toluene contains hydroxy group and benzene ring, then it is known as cresol. That is, if the methyl group is attached to benzene ring, then it is known as toluene. If toluene contains hydroxy group on benzene ring, those compounds considered as cresols. Based on the position of the methyl and hydroxy groups, they may be different. If they are at 1-2 position, that is ortho position, those called as orthocresol, it is orthocresol. If methyl group and hydroxy groups are at 1,3 position, sorry, 1,3 position, those called as metacrystals. If methyl and OH groups are para position to each other, those called as paracrystal. So, although metapheracrysols or positional isomers. Next classification of hydroxy compound. The next parameter to classify hydroxy compounds is number of hydroxy groups present in a given hydroxy compound. The first parameter is based on the nature of the R in ROH. The second parameter per classification of hydroxy compound is number of hydroxy groups present in a given hydroxy compound. Based on number of hydroxy groups present in a given compound, the compounds classified into different types. They are first one, monohydric compounds. Mono means single. Hydric, here the hydroxy group, OH group also named as hydric group. So monohydric group means, monohydric compounds means the compounds or the hydroxy compounds which have a single hydroxy group or single OH group, generally known as monohydric compound. All the hydroxy compounds, whether they are aromatic or aliphatic in nature, whatever it may be, which have single hydroxy group, falls into the category of monohydroxy compound or monohydric compounds. Next, dihydric compounds. Dihydric compounds also known as diols. According to IUPAC nomenclature, hydroxy compounds named as ols, suffix is ol, functional group suffix is ol, that is alkanols. So here ol indicates alcohol, hydroxy compound. Dihydric compounds also known as diols. Di means two, so it contains two hydroxy groups, that is diol or dihydric compound is nothing but it is a hydroxy compound which have two hydroxy groups. This dihydroxy compound or dihydric compounds further classified into different types based on the location of the two hydroxy groups in the compound. They are the first one. If the two hydroxy groups are situated on the same carbon or connected to the same carbon, those compounds generally considered as monohydric, considered as gem diols. In diols, if the two hydroxy groups connected to the same carbon, those called as gem diols. Gem diols generally obtained from the hydration of the carbonyl compounds. These are unstable compound, that is gem diols are unstable because if the carbon is attached to two hydroxy groups, it easily loses one water molecule to form corresponding carbonyl compound from which it obtained. So gem diols are generally unstable one. If the carbon which is attached to two hydroxy groups further attached to more electron withdrawing groups or group, then it gets some stability. For example, in the case of chloral, that is CCl3CHO, that is trichloroacetaldehyde. If you hydration of trichloroacetaldehyde, we get chloral hydrate. It is stable one. Chloral hydrate is stable. It is example for gem diol and also stable because the carbon which is attached to two hydroxy groups is further attached to CCl3 group, that is more electron withdrawing chlorine atoms. So the chloral hydrate is somewhat stable, though it contains two hydroxy groups on the same carbon. That is gem diol. In the diol classification, the first one is gem diol. In gem diol, the two hydroxy group attached to the same carbon atom. Next, second one, vicinal diols. Vicinal diols means it is the one type of diol or dihydric compound where the two hydroxy groups are located or situated on the adjacent carbons or vicinal carbon. Adjacent carbons are nothing but vicinal carbons. So that is the carbons attached to vicinal, the hydroxy groups attached to vicinal carbons, then it is known as vicinal diol. Generally, vicinal diols obtained from the hydrolysis of epoxides. They also obtained from the oxidation of alkenes. By oxidizing alkenes with potassium permanganate or osmium tetroxide, we can get corresponding vicinal diols. These vicinal diols also known as glycols because these diols, that is vicinal diols, are sweet to taste, so they are also known as glycols. Glyco means sweetness, indicates sweetness, so vicinal diols also known as glycols. Okay. Next classification in the diols. First one is gem diol, vicinal diols. There are other diols where the two hydroxy groups situated on different carbons in the compound. They may be situated at 1,3 position. Then it is known as 1,3 diol. They may be situated at 1,4 position. Then it is known as 1,4 diol. They may be situated at 1,5 carbons. Then it is known as 1,5 diol. Okay. This is about the classification of diols. Next, examples for monohydric as well as dihydric compounds. Okay, monohydric compounds. Monohydric means they contain only single hydroxy group. So methyl alcohol, ethyl alcohol, and propyl alcohol. Sorry, 1 minute. Example for monohydric compounds. Monohydric contain only one hydroxy group. So all the hydroxy compound which have single hydroxy group generally falls into monohydric category. So ethyl alcohol, methyl alcohol, benzyl alcohol, phenol, paranitrophenol, orthonitrophenol, cresols, all monohydric compounds, monohydroxy compounds are example for this category. Next, diols. Diols, it contains two hydroxy group. For example, ethylene glycol. Ethylene glycol. Here, the two CH2OH groups attached to each other. That is, it contains two OH groups. That is oxidation of ethylene. On oxidation of ethylene, we get ethylene glycol, or hydrolysis of ethylene epoxide also produces ethylene glycol. It is example for diol. It is aliphatic diol. There is aromatic diols also. It may be resorcinol, catechol, quinol. In catechol, these three compounds, resorcinol, catechol, quinol also known as hydroquinone. These three compounds are positional isomers. If the two hydroxy groups are at 1,2 position, those called as catechol. It is called as catechol. If two hydroxy groups are at 1,3 position, that is meta position, then it is called resorcinol. If two hydroxy groups are located at 1,4 positions, then it is known as quinol or hydroquinone. These are example for some dihydric compounds or diols. Next, trihydric compounds. Trihydric compounds means the hydroxy compounds which have three hydroxy groups, generally known as trihydroxy or trihydric compounds. These trihydric compounds, also known as triols, according to IUPAC nomenclature, they called as triols. In triols, the three hydroxy groups may be situated at different positions. If the three hydroxy groups situated on the same carbon, it is unstable, then it easily loses one water molecule to form corresponding carboxylic acid. If one hydroxy group is situated at one position and the remaining two hydroxy groups situated on the same carbon, then also the two hydroxy groups loses a water molecule to form corresponding hydroxy ketone. Okay. Next, polyhydric compounds. Polyhydric compounds are nothing but the hydroxy compounds which have more than three hydroxy groups, generally known as polyhydroxy compound or polyhydric compounds. There are some examples for trihydric and polyhydroxy compounds. In the first case, that is trihydric compounds or triols. Examples are the aliphatic trihydroxy compound is best example is propane 1, 2, 3 triol, which is also known as glycerol or glycerin. Glycerol, also known as glycerin. It is trihydroxy, aliphatic trihydroxy compound. That is, it is propane derivative. Here the remaining three, this one, sorry, this one, these three are example for aromatic trihydroxy compound. These are also known as position isomers. Here the second one is hydroxyquinol. That is by substituting one of the hydrogen of the hydroquinone or quinol with hydroxy group, then we get hydroxyquinol. The third one is pyrogallal, where the three hydroxy groups are situated side by side, or they are located at 1, 2, 3 positions. That is 1, 2, 3 trihydroxybenzene, 1, 2, 3 benzene triol, generally known as pyrogallal. In the fourth one, the three hydroxy groups situated at 1, 3, 5 positions. It is generally known as 1, 3, 5 benzene triol. The general name of this 1, 3, 5 benzene triol, fluoroglucinol. That is trihydric aromatic compounds are hydroxyquinol, pyrogallal, fluoroglucinol. These are positional isomers. Example for polyhydroxy compounds. There are two examples. One is sorbitol and mannitol. Sorbitol, mannitol. These sorbitol and mannitols are derivatives of, they are obtained from the glucose and mannose respectively on reduction process. That is, on reduction of glucose, we get corresponding sorbitol, that is polyhydric compound. On reduction of mannose, we get corresponding mannitol. These are example for polyhydric compounds. Okay, fine. Next, monohydric compounds or monohydric alcohols. Here, the aliphatic monohydroxy compounds or monohydric alcohols, they further classified into three types based on the nature of the carbon atom to which the hydroxy group is attached. The first one is primary alcohol. Primary alcohols are nothing but these are the monohydric alcohols where the hydroxy group is attached to primary carbon. Next, secondary alcohols. Secondary alcohols are nothing but these are one type of monohydric alcohols where the hydroxy group is attached to secondary carbon. If the hydroxy group attached to primary carbon, those called as primary alcohols. If the hydroxy group attached to secondary carbon, those called as secondary alcohols. Okay, fine. Next, tertiary alcohols. Tertiary alcohols means these are also one type of monohydric alcohols where the hydroxy group is directly attached to tertiary carbon. Here you may have a doubt, what is primary carbon, what is secondary, what is tertiary carbon. Here the notes indicates the primary, secondary, tertiary carbons. First one, primary carbon. Primary carbon is nothing but it is a carbon which is attached to none or which is attached to a single carbon. That is the carbon, single carbon atom containing alcohol, or the carbon in hydroxy group which is attached to one more carbon, generally known as primary carbon. Primary carbon means the single carbon or the carbon which is attached to one more carbon atom, generally known as primary carbon. In methyl alcohol, in ethyl alcohol, the carbons are generally primary carbons. Here it is single carbon in methyl alcohol, but in ethyl alcohol the two carbons are attached to a single carbon. Here the hydrogens which are attached to primary carbon considered as primary hydrogens. Next, secondary carbon. Secondary carbon is nothing but it is a carbon which is directly attached to two more carbon atoms, generally known as secondary carbon. Example is propanol. That's secondary alcohol example, propanol. Here the first and three, these carbons are primary carbons, but the second carbon is secondary carbon because it is attached to first carbon and the third carbon. So the middle carbon is secondary carbon. Okay, next, tertiary carbon. Here the in the case of secondary carbon, the hydrogen the hydrogen which are attached to secondary carbon, generally known as secondary hydrogen. Hydrogen attached to primary carbon, known as primary hydrogens. Next, tertiary carbon. Tertiary carbon is nothing but it is a carbon which is directly attached to three more carbon atoms. The best example is tertiary butane. Tertiary butane. Here the carbon is tertiary carbon. Here the carbon, the three carbons are primary carbons. Here tertiary carbon is directly attached to three carbon atoms. So this is tertiary carbon, and the hydrogen is tertiary hydrogen. Okay, fine. Next, there are some example for primary, secondary, tertiary alcohols. Example, primary alcohols: methyl alcohol, ethyl alcohol. In methyl alcohol, the hydroxy group attached to primary carbon, so it is primary. In ethyl alcohol also, the hydroxy group is attached to primary carbon, so it is also example for primary alcohol. Next, example for secondary alcohols. The best one example is isopropyl alcohol, which is also known as 2-propanol, and the other one is 2-butanol. In isopropyl alcohol, the OH group is attached to secondary carbon, so it is secondary alcohol. In 2-butanol also, the hydroxy group is attached to secondary carbon, so these are example for secondary alcohol. Tertiary alcohols, example for tertiary alcohol. The best example for tertiary alcohol is tertiary butyl alcohol. where the hydroxy group is attached to tertiary carbon. So it is example for tertiary alcohol. Okay, fine. Next, nomenclature of hydroxy compounds. To name all the hydrocarbons as well as hydrocarbon derivatives, there are two methods. One is general system or common system. The second one is IUPAC system. So here also, to name the hydroxy compound, the two main systems used are common system and the IUPAC system. The first one is common system. In common system, generally the hydroxy compound named as alkyl alcohols in the case of aliphatic hydroxy compound, and aryl alcohols in the case of aromatic hydroxy compounds. In common system, in order to name the hydroxy compound, we have to name the hydrocarbon radical. After that, we have to add alcohol suffix to the name of hydrocarbon radical. Then we get the name of that particular hydroxy compound according to common system. In general, in the case of aliphatic, the hydroxy compound known as alkyl alcohol. In the case of aromatic, they known as aryl alcohols. Okay. For example, methyl alcohol, ethyl alcohol, just like. In the case of aromatic hydroxy compounds, according to common system, they known as aryl alcohols. Here, the benzene, the hydroxy compound derived from benzene is generally known as benzenol, benzene plus ol, benzenol. This benzenol generally considered as phenol. So, in the case of aromatic hydroxy compounds, the compounds named as derivatives of the benzene or derivatives of the other arene compounds. Okay, fine. Next, the second one is IUPAC system. In order to name a given particular organic compound according to IUPAC system, we have to follow some specific rule. That is, IUPAC system gives a specified name to each and every compound, organic compound. It is internationally adopted system, not a locally one. IUPAC means its extended form is International Union for Pure and Applied Chemistry. In order to name the alcohol according to IUPAC system, we have to follow some specific rules. In these rules, the first step we have to find out the longest alkyl chain or the longest hydrocarbon chain as a parent chain. We have to find in the first step we have to find out longest hydrocarbon chain as a parent chain in a given hydroxy compound. Next, after finding the longest hydrocarbon chain or parent chain, we have to give numbers or we have to assign numbers to the carbons of the parent chain in a way that the carbon which is directly attached to hydroxy group gets minimum or least number either from left side or from right side. But the condition is the carbon attached to hydroxy group must get least number. That is the correct order to give or to assign numbers to the carbons of parent chain. After giving numbers, after completion of giving numbers, we have to name, or we have to find out the corresponding hydrocarbon, that is alkane name. From that alkane name, we have to remove E and have to add OL suffix to that particular alkane name. Then we get corresponding hydroxy compound name. That is, by replacing E from the alkane and adding OL suffix, we get the name of the hydroxy compound as alkanol. So, according to IUPAC nomenclature, alcohols are aliphatic hydroxy compounds named as alkanols. Okay, fine. After naming the parent chain, or after naming the hydroxy compound or alcohol, we have to find out other substituents present in the given hydroxy compounds. If there is any alkyl groups or any other groups which have less priority than that of the hydroxy group. After finding the substituents present in the given alcohol, then we have to name that particular substituents along their positions and along their numbers as a prefix before the name of the particular alcohol. This is the complete naming of the given alcohol or aliphatic hydroxy compound. In general, the aliphatic hydroxy compounds or alcohols simply named as alkanols according to IUPAC nomenclature. Here there are some example. Methyl alcohol, it is according to IUPAC it is known as methanol. Ethyl alcohol, according to IUPAC it is known as ethanol because it is derivative of ethane. So replacing E with ol, we get ethanol. Here the other one is this compound. Here if you give number, the numbering must be from right side in order to get list number. So 1 2 3 4, so it is 4 carbon hydroxy compound, so it is derivative of butane. So the position of the substituent is 3, that is the chlorine is substituents here. So the particular name is 3 chloro 1 butanol or 3 chloro butane 1 ol according to IUPAC. Next, aromatic hydroxy compounds nomenclature according to IUPAC system. Here the phenols, aromatic hydroxy compounds generally named as aromatic hydroxy compound, generally considered as phenols. So there is no specific rules in order to name the aromatic hydroxy compounds according to IUPAC system. So simply they named as derivatives of benzene as well as derivatives of phenols. Okay, fine. Next, there are some examples for the name of aliphatic as well as aromatic alcohol. Here the first one is propanol. First one is, it is propanol, 3 carbon containing hydroxy. It is also 3 carbon containing hydroxy compound, but the position of hydroxy group different, so it is 2 propanol. This is 5 methoxy 2 hexanol. It is longest chain is 6 carbon, so parent hydrocarbon is hexane. The substituent is methyl, situated 5th position. So the hydroxy group located second position. So the overall name is 5 methyl 2 hexanol, or it is also known as 5 methyl hexane 2 ol. Okay, fine. Next, okay, example for some phenols with their names. Here it is, the first one is, it is 2 methyl phenol. It is also known as chrysols as we discussed earlier. It is 1 comma 2 benzene diol. The general name is catechol. It is, this is this positional isomers of orthocresol. It is so 1 comma 3 position. So metacresol, it is positional isomer of 1 comma 2 1 comma 2 benzene diol. So it is meta isomer. So it is 1 3 benzene diol or resorcinol. Here it is orthonitrophenol or 2 nitrophenol. It is positional isomer of catechol and resorcinol. It is hydroquinone or quinol, simply quinol, or 1 comma 4 benzene diol. This is 2 comma 6 comma dibromo, so comma 6 dibromophenol. This is naphthalene derivative. So it is position of hydroxy group is first. So it is 1 naphthol, or it is also known as alpha naphthol. These are the examples for some phenols with their names. Okay, in this topic till now we discussed about the introduction of hydroxy compounds as well as classification and nomenclature of the hydroxy compound. Okay, thank you very much for your patience. Thank you. In the next part I will discuss about the preparation methods, properties, as well as application of hydroxy compound. Thank you one and all. Thank you.